Here we're going to solve for the linear speed in this word problem. So we have the following problem. The tires of a bicycle have radius 13 inches, and the bike is moving, the tire is turning at a rate of 215 revolutions per minute. And the question is, how fast is the bike going in miles per hour? So when we're given 215 revolutions per minute, this is a component of angular speed. So angular speed is measured in radians per minute. We can convert revolutions per minute into radians per minute. And so since I have this angular speed, which is an angle, the radians per minute, I can convert that then into linear velocity by using the following equation. So things I'm going to need, I need to know that the linear speed is equal to the radius times omega, omega being the angular velocity, the angular speed. So let's go ahead and begin. First, I need to find omega. So I'm seeking omega. I'm looking for an answer that is I'm seeking, let me write that down, seeking radians per time. Now, the problem statement, I'm given revolutions per minute, but I'm going to be looking for miles per hour. So what I'm actually seeking here is radians per hour. So that is what I'm seeking. Let's go ahead and find that. Omega, I have that I'm going 215 revolutions per minute. I know that each revolution is 2 pi radians. So, let's do parentheses here. 2 pi radians per revolution. My revolutions kind of cancel. I end up with 430 pi radians per minute. Now, I'm going to leave the pi there. I don't ever like to introduce rounding errors, so I don't use a decimal approximation for pi until I reach the very end. Now I have radians per minute, but I really want radians per hour, as I said in my problem statement here. So let's continue. I'm going to cancel the minutes. That means that whatever I multiply this by has to have the minutes in the numerator in order to appropriately cancel. So I'm going to copy this down. 430 pi radians per minute. Well, I know that there are 60 minutes in 1 hour. The minute units cancel, and I end up with 25,800 pi radians per hour. This was what I was seeking, so that's part of the way there. Now I know what my radius is, and I should be able to find my linear speed. So let's go ahead and do the next step. I'm going to use this omega, this angular velocity, in the next step. So V equals R times omega. The radius is inches, right? 13 of them. So V equals 13 inches times 25,800 pi radians per hour. Now, radians, that is a unitless measure. So I'm going to stop saying radians because it is a unitless measure of angles. So it's not introducing an additional unit into my final answer here. However, I want miles per hour, and instead I just have inches per hour. So I'm going to need to convert inches into miles. So again, I want to choose my numerator and my denominator based on what I want to cancel. So I know that I'm going to change into feet, so I'm going to put 1 foot on the numerator and 12 inches here in the denominator. That cancels those. Then I still need to cancel, I need to end up in miles. So I'll put 1 mile in the numerator here and 5,280 feet per mile. I just want to emphasize that what we're doing here when we do these conversions, 1 foot equals 12 inches. So when I multiply by 1 foot over 12 inches, I'm multiplying by 1. I am not changing the value. I'm not changing the value. I'm only changing its form. So we do this a lot in mathematics. We multiply by 1. This allows me to change the form of the answer without changing its value. Anyway, we will proceed. So my feet here now will cancel those units, and I'm left with miles in the numerator and hours in the denominator. I'm happy. That's what I was looking for, miles per hour. So I multiply this out. I will have 13 times 25,800 pi divided by 12 times 5,280. When I multiply, and this is miles per hour. When I multiply all of this out and do my decimal approximation of pi, I might end up with 16.63 miles per hour. And that is how we solve this word problem to get the linear speed of this bicycle.